Problem number 22, using C++. I like C++ more than Python, even though it can at times be a lot more verbose. This particular solution was pretty simple in terms of the number of lines and quite beautiful actually to look at as well. I've never been a big fan of not having closing and opening parentheses and using just indentation in order to define function scope. Still kind of getting used to that. So the idea here is this is the actual backtrack method inside of generate parentheses. This is going to contain all the solutions, the vector string solutions. So it is in scope for the backtrack lambda to be able to access and push back all possible solutions. Here you can see that the length of the string is compared to n times 2. That's times 2 because you have the same amount of open and the same amount of closed parentheses. So once you exhausted the limit, that's going to be n times 2, so that's going to be a possible solution. And in the tree traversal of permutations, first you will see that it'll call backtrack again every time here on the open until it exhausts all open parentheses. So you'll see 3 open parentheses. Then it'll call backtrack 3 more times for all the closed. So that's 6 calls. So you'll get 3 closed. So once you have that, it'll start backtracking. Now the reason you don't see any deletion off of the string is because we're using a constant string reference, which creates a copy right before the call, right here when the current string gets a parenthesis concatenated to it. So you don't actually see any backtracking in the backtracking algorithm, and I think that's kind of nice too. So I think it's a very elegant solution, just about 20 lines or so in order to get everything going with valid test method here. Boom, you can see it run. Number of solutions 5, and so once you get the 3 parentheses here popped off, you get also one of the open parentheses popped off. That was the last call before they started going to the back. So one of the open gets popped off, and then that particular method starts traversing its tree and closes, and then another open is available because the close will start going down the same logic path and see that, oh hey, there's one more open I can use, and so it'll place an open and then a closed and a closed again, so because it'll exhaust all open parentheses here. So I'm not going to go through the logic tree exactly, but here's the code, and it's pretty performant in terms of complexity. I haven't looked at the other ones. They're usually pretty tricky. They will do some insanity. As you can see here, they actually push and pop back. There's the generate parentheses, and then there's the private helper. They just called the gen paren here also. Okay, so very difficult to read solution, very ugly. I think all this popping and pushing, not my style, quite honestly. So even onto the string, as you can see, they pop, push and pop constantly, and I'm not sure. I just find this kind of amateur in terms of the design of the readability, but these are problems not necessarily for other humans, but just to pass. So with a nice readable solution, we're getting 4 milliseconds of runtime. I think it's good enough, but maybe there are other tricks. Still, this See a lot of. This one's alright, but uses an unordered map. Not sure, haven't went through this logic yet. Again, I really like this. It's pretty simple. We have a vector of solutions waiting to receive in the generate parentheses scope. We have a lambda. See, you don't really see lambdas being used in modern day C++ solutions. At least I have yet to find one, but I do see some crazy hijacking of input. At times people write some monster code. So this is my solution to the generate parentheses leetcode problem number 22. Cool.